CAP theorem. CAP theorem was proposed by Eric Brewer in Berkeley and which was subsequently proved by Gilbert and Lynch. In a distributed systems, you can specify at most 2 out of 3 different guarantees, which is now specified as, which is known as the CAP theorem. Let us see what these 3 different guarantees, 3 different things are. So, the first one is called consistency, the second one is called availability, third one is called partition tolerance. CAP theorem says that out of these 3, at most 2 can be the guaranteed by any systems. So, let us see the consistency, that means all the nodes see the same data at any time, or the read returns the latest return value by any client. So, that is called consistency. That means at all points of time the node will get the most recent data at any point of time whenever it is being referred or it is being accessed by the read operation. So, whenever a read operation is performed, it will return the latest write by the client. If that is guaranteed at all points of time, then it is called consistency. Availability says that the system allows operation all the time and operations return quickly, meaning to say that the operations, the system always is operating, and whenever is being accessed it will perform, it will return the operations very quickly. So, this is called availability. Third criteria is called partition tolerance, that is the system continues to work in spite of network partitions. So, the CAP theorem says that out of these 3, so CAP CAP, that means consistency, availability and partition tolerant, in short it is called CAP theorem. CAP theorem says that out of these 3 different parameters, at most 2 can be guaranteed at any time by the system. So, this is the design issue that we are going to see what is the implication of this CAP theorem over different NoSQL systems which are being available at this point of time. Now, let us see all these 3 different things which is specified in the CAP theorem. That is, the first one is, let us understand about the availability and what is the importance of availability. Availability says that read and write will complete reliably and quickly at all point of time. So, if we measure these are read and write operation times, and let us say that this particular measurement will have an increase of 500 millisecond latency, then let us see what is the implication of most of the operations in the company. So, this latency of read and write of 500 milliseconds, it is shown that for the companies like Amazon or a Google has caused a drop of 20% in their revenue model, meaning to say that, so Amazon.com is dealing with the sales of these items. So, if there is a latency of 500 milliseconds in these performance, then obviously customer will churn and therefore, they will drop in their revenues. So, at Amazon each added millisecond of latency implies 6 million yearly loss. So, a user cognitive drift is there and if more than a second elapses between the clicking and the material appearing, the user's mind is already somewhere else, and this will lead to a churn in the customers. In any business. So, this is a most important parameter in some of the cases. So, the companies like online which are dealing with the e-commerce online sales, that is Amazon company or the Google, which taps the advertisements and other such product which are and services online, has to ensure high availability and not only reliability, but it has to be very quickly, that is the latency also has to be very minimal, so that the users can get the services. So, therefore, a service level agreements written by the providers predominantly deal with the latencies which are faced by the clients, and therefore, the availability is also one of the most important parameter or criteria in the CAP theorem. Now, second criteria, which is called a consistency of a CAP theorem C of, that is called consistency. Consistency says that all the nodes see the same data at any time or returns the latest return values by the client, meaning to say that the nodes whatever updates are happening on the nodes by different write operations, so they are updated, they are up to date. So, whenever a read is requested, it will always return the latest write operations which are done by the any client. So, reads are very latest returns, read returns the very latest information which are written by the client. If that is maintained at all points of time, that is called consistency. Now, when you access your bank account or investment account via multiple clients via laptop, workstation, phone, tablets, etc., you want these updates to be done from one client to be visible to the other clients. It is not that if you have done through the mobile phone and your mobile phone updates are and you are now accessing or reading via laptop, they may not get the recent update. If that is the case, then it is not a consistency. So, similarly, when thousands of customers are looking to book a flight ticket, all the updates from a client should be accessible by the other client in the reservations, airline reservations to booking a tickets. So, consistency also is going to be an important parameter. Now, another parameter which is there in CAP, P stands for the partition. So, partitions can happen across data centers when the internet gets disconnected. So, this can happen by way of internet outages, internet router outages, or undersea cable cuts, or DNS not working. In all these scenarios, you will see that the network gets partitioned and the entire data center, some of the data centers may be disconnected and partitioned. So, partition tolerance, partitions can occur within the data center, within the rack or switch outages and so on. So, rack switches also can basically ensure or induce these partitions into the network. So, still the desire system, the desire is that system to continue functioning normally under the partition, that is why it is called partition tolerance. Partition tolerance ensures the functioning even in the face of partitions, or it is also called a network failures. Now, the CAP theorem fallout, since the partition tolerant is essential in today's cloud computing systems, the CAP theorem implies that a system has to choose between the consistency and the availability. Now, we will see the Cassandra. So, Cassandra uses eventual that is called a eventual consistency, which is also a weak form of consistency, and then it ensures, it also uses the availability and partition tolerance. So, Cassandra uses A and P of a CAP where C is being compromised, or that is called eventual consistency or a weak form of consistency. Similarly, the traditional databases management system, we see that provides the strong consistency, that is, it provides C and over availability under the partition. Since the database is on the same system, hence the partition is already partition will not happen, hence the CAP is always satisfied or guaranteed in the traditional RDBMS systems. So, CAP trade-off, let us see that starting point for this NoSQL system, the CAP trade-off has to be there. So, in a distributed storage system can achieve at most 2 out of 3, at most 2 out of this consistency, availability and partitioning. So, when the partition tolerance is important, then you have to choose between consistency and availability. So, same thing is happening in the Cassandra system. So, we have to choose between consistency and availability. So, Cassandra chooses availability and a weaker form of consistency in Cassandra. Similarly, in React and Dynamo and Vodelmot also uses the partition tolerance and availability with a weaker form of consistency. Now, as far as RDBMS is concerned, so RDBMS which is not replicated, which ensures the consistency and availability, and there is no partition, hence consistency and availability are ensured in RDBMSs. Now, HBase prefers partition tolerance and consistency over availability. So, we will see that HBase and hypertable, big table and spanner uses the consistency and partition tolerance over availability. Let us see the eventual consistency, which is a weak form of consistency. Which is supported in the Cassandra. Let us go and detail see how the Cassandra is trading off with the consistency to ensure the partition tolerance and the availability. Now, if all the writes stop to a particular key, then all its values in the replica will eventually converge, meaning to say that if some of the writes do not takes place or do not gets updated at some of its replicas, then those replicas will be updated or will become consistent after some point of time, hence they will be eventually converge. So, if the write continues, then system always tries to keep converging. So, this way the moving wave of the updated values lagging behind the latest values sent by the client. So, these waves will move over the time. So, that says that moving wave of an updated values will be lagging behind the latest values sent by the client, but always tries to catch up. So, this difference will always be there. Now, if the number of new values are not coming, then obviously eventually it will become the latest one, after eventually it will be converging it. So, if the write continues, then the system tries to keep converging, and this may still return some of the stale values to the client if many back to back write operations are there, but it will work fine when there are few periods of low writes, so the system can converge quickly. Now, let us compare the RDBMS with the key value stores. So, RDBMS provides the ACID properties, atomicity consistency, isolation and durability, whereas key value store like Cassandra provides the base property. Base is basically available soft state eventual consistency. So, basically available means they are it provides the availability assurance, and soft state eventual consistency. Soft state that we have seen in the form of caching in the memory operations. Most of the table properties are stored in cache, and that is in the form of mem table. And eventual consistency means finally everything will be updated, that is called eventual consistency, not immediately, but eventually it will be updated. So, it prefers the availability over the consistency in the base model. Now, let us see the consistency levels which are supported in the Cassandra. Cassandra has different consistency levels. So, the client is allowed to choose the consistency level for each operation, that is read and write among these different consistency levels. So, they are one, that is any, second type of consistency level is all, third is 1, and fourth is quorum. Let us understand one by one all these consistency level. So, any consistency level by mean any consistency level, that means any server may not be the replica is can allow this operation to be complete. So, this becomes the fastest because the coordinator caches the write operation and returns quickly to the client to perform this read and write operations. Hence, this is the fastest one. The second one is called all replicas. That means it ensures that the read and write operations requires to ensure that it has to be updated at all the replicas. So, this is a kind of a strong consistency. So, it will provide, if the consistency level is all, then it will be the slowest one. Third one is called 1, that is at least one of these replicas gets updated. So, it is faster than all, but it is slower than any. Why? Because it cannot tolerate the failure of all of the replicas. And fourth one is called quorum. Quorum says that quorum that means quorum across all the replicas in the data center is to be updated. What do you mean by the quorum that we are going to see? So, quorum is between the all and 1. So, quorum is some number k. So, we are going to see how many replicas are required to be updated under the quorum system. So, quorums for consistency, quorum says that majority. So, if there are in this example there are 5 different replicas. So, the quorum says the majority means more than 50%. So, that becomes the 3. So, minimum at least 3 different quorums, different replicas are to be updated. So, for any two the properties of a quorum which has to be satisfied is that if any two quorums, if we take the intersection, then there must be a common replica or common servers between any two systems. So, any two quorum where intersect, client 1 does the write operation in the red quorum and the client 2 reads from the blue quorum, then it will get the update from because there is a common server in both the quorums. So, at least one server in the blue quorum gets the latest write. So, quorums are faster than all, but ensure the strong consistency. So, quorums let us see in more detail. So, several key value pairs, that is NoSQL store, React and Cassandra uses the quorum. So, reads, that is the client specifies the value of R, which is the value of the quorum, which is less than the number of replicas. So, R is the read consistency level. So, coordinator waits for R replicas to respond before sending the result to the client. In the background, the coordinator checks for the consistency of remaining n minus r replicas and initiate the read repair if any. So, meaning to say that not only it the read is being satisfied by specifying the r number of replicas, but what about the remaining replicas, that is n minus r, whether are they consistent or not, that also required to be checked for the consistency of the remaining replicas. So, that has to be done in the background, and if they are inconsistent, then the read repair is to be initiated, so that eventually they may be consistent at all the levels. So, read sometimes does the read repair to ensure the eventual consistency. Now, quorums, the write come into flavor when a client writes W into the number of replicas less than total number n, then write consistency level we have to specify. So, the client writes a new value to W replica return. There are two flavors. So, the coordinator blocks until the quorum is reached, or it will be in the asynchronous, that means it will just write and returns back. Now, if let us say R is the read replica count and W is the write replica count, then there are two necessary conditions in the quorum to be satisfied. One is the write replica count plus read replica count must be greater than n, and W plus W is equal to or also greater than n. So, that becomes W is greater than n by 2. Now, we have to select these values based on different applications when there are very few writes and very few writes and reads, then W is equal to 1. When there is a great for read heavy workloads, then write is n and read is 1, and when there is a grade for the write heavy workloads, then W is n divided by 2 plus 1, whereas and R is equal to n divided by 2 plus 1, and it is great for the write heavy workload with mostly one client writing per key, then W is equal to 1 and R is equal to n. So, these are different replica count for read and write can be set according to the applications which are there. So, we have seen the quorums across all the replicas in all the data centers, and it ensures the global consistency, which is still a fast one. So, local quorums in a coordinated data center are faster, only waits for the quorum in the first data center client contacts. Each the quorum in every data center, let each data center do its own quorum and support the hierarchical replies. So, the type of consistency which Cassandra provides is called eventual consistency. What are the other weak forms of consistency models which are available in the practice, that we will see in the next slide.